Hi everyone. Now we are going to see about mm, the formulas for the arithmetic progression and geometric progression in the multi-dimensional level or hyperdimensional level. So AP is like more into scientific terms. We can say like velocity. So velocity equal to speed divided by time. So but the velocity will gradually increase, and then the GP is kind of a acceleration. So GP will be like acceleration equal to velocity divided by time. So this is contains the ratio. For example, arithmetic progression, if there is a number between two different number values remains the same. From if you are sequentially saying like 1 2 3 4, so the differences of 1 is considered as a arithmetic progression, whereas a GP will be like a ratio. The ratio need to be similar. So if I say like 1 2 4 8, so the sequentially when I'm arranging numbers, 2 divided by 1 equal to 2, 4 divided by 2 equal to 2, 8 divided by 4 equal to 2. So the principles remains the same for that hyperdimension also. So for example, when I'm going into arithmetic progression, so this is like long back I tried to work it out. And if I take this formula, so this is like a formulas arrangement. So it's kind of an algorithmic formula notations I created. So here NF is the first number, and xi minus 1 di will be like any a number of differences. So there will be like a number of differences. I'm marking it out. So for example, I'm taking like a fourth dimension. I'm taking that as an example of fourth dimension. This one is a fourth dimension. And so if I apply the formula for this one, so this will be the values I'm getting. I mean, the extending the capability of summation value. So I'm getting like a four different results. The D1, D2, D3 are D4 are like row, column, phases, and cube, which means, let me tell you that examples. So take this cubic, okay? In this cubic, um, this is a row, right? This is a row. So each row 11, 13, 12, 14. So each row value, if you see 11, the difference between these two is 2. The difference between the two is 2. Same. So this is a D1. And then if you take an example of um, column value, okay? In this column value, if you see that differences of this particular values 13, 11, 14, 12. So differences are 2. And then this one is this particular one 12, 12, 11, 13, 14. The differences is 1. So the uniqueness can be handled in the different shapes. And then if you take it like exact phases, this is one phase, this is one phase, and backward this is another phase. Okay, so if you see, this is a line where the difference is, which means the number, if you take a number 11, 16, 12, 17, 16 minus 11, 5 is the difference, 17 minus 12, 5 is the difference, and then 13, 18, 13, 18, 14, 19. So if you see, the differences are though also same. And likewise, if I take an example of cube, this is a one cube and this is another cube, okay? And if you take an example of, I am taking one particular examples. So if you see like 1 6 these are like a diagonal different phases. And if you take an example of one cube to another cube, this is a 1 and this is 11, difference is 10. And if this is a 6 and this is a 16, the difference is 6, so differences is 10. That if you see like one cube to another cube, the difference is 10. So this particular formula deals with this particular combination of four different factors. So that's what I explained here. D1 is row, then D2 is column, and D3 is phase, and D4 is nothing but it's a cube. The one cube internal cube to the external cube. What is the value is residing? Internal cube to external cube. All this the value is differences is 10. And then when I'm trying to apply the formula, say like this is a problem statement. I want to discover the values which is residing in the value of fifth row, fifth column, fifth phase, and then fifth cube. What value I want to derive? So that value I want to understand. So what I'm doing it here, the starting number of the formula value is 1, and then what I want to derive, I want to derive that fact. Yeah, fifth row, fifth column, fifth phase, and then the fifth cube, fifth fifth row, fifth column, and the fifth phase, and then fifth cube. And then if you see that each differences mm, each differences are same to 1 10. So by applying this particular formula, I'm getting 40 28 12 73 is the answer. So if you see this 73 value I'm getting. So what is this? So there is like a one cube and then second cube 5. So if I plot that different cube 1, cube 2, cube 3, cube 4, cube 5. So this is the fifth cube. In this fifth cube, I want that fifth row. So it is like a fifth cube by default having fifth row, fifth column, fifth. This is like diagonals. So if there is like the clear separation is about fifth phase, and then the final value, this is the one. So that is the point I'm trying to bring it here. So likewise another example, I drove it here. So I'm taking as a simple example of cubic number. So what I'm trying to find it out, it's a very simple one. So it is like this particular column. So the values are differences are 5 1 and then 2 2. So if you see that the first number is 3, the first number is 3, and then imagine this particular problem statement. What I am trying to build, it is, I want some numbers, I want to find the number which is 100th row, 100th column, and the 100th phase. So by using these differences of each phase and what I'm trying to build, what I'm trying to find the for value is this particular coordinates. It's, remember, this is a coordinate: 100th x-axis, 100th y-axis, and 100th z-axis. So what will be the value? So if I plot the information, so if this is the first number is 3, and then the formula is x minus 1 d1, x minus 2 d2. So likewise I plotting, and what I'm finally getting, the value is 795. So which means if I'm having a three-dimensional cube, if I'm having the pieces of information about 100 column, 100th column, 100th row, and then 100th phase, I'm getting the value of 795. So this is about all about arithmetic progression. And then let's go into geometric progression. So as I told about, like, geometric progression is kind of acceleration equal to velocity divided by time. So it's kind of a ratio, the ratio between the two differences, two any dimensional differences will be like uniqueness, which has been calculated via ratios. So this is a general notation of hyperdimensional formulae. So it's a kind of an algorithmic approach as well. So taking an example of fourth dimensional geometric progression, the term I want to discover is x1, x2, x3, x4, that is the coordinates. So how I am representing, since it's r minus 1 power x1, x1 minus 1, x2 minus 2, r4 x up to r4 x4 minus 1. So let me jump with the formula. Here in this example, I'm having fourth dimensional hypercube. Hypercube. So if you see these numbers, so let's see that outermost cube is starting with 1. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 1, 2, 3, 4. 1, 2, like this: 1, 2, 3, 4. Sorry, 1, 2, 3, 4. 1, 2, 3, 6, 4, 12, 8, 24. So if you see the ratios for each one, 2 divided by 1, 2, 6 divided by 3, 2, 2 divided by 1, no, 3. And then if you see like this, 1 divided by 3, sorry, 3 divided by 1 is 1, 6 divided by 2, 3. So likewise the ratio what we are achieving is unique ratios. So non fourth dimension have this particular category. The ratio of one first dimension is 3. So I mean, it's kind of a row, you can assume. And then row r2 is kind of a column ratio. Column ratio is 2. And then r3 kind of a phase ratio, so it's coming as 4. And then finally cubic ratio, so one cube to another cube ratio is 5. So what I am trying to achieve, I'm nothing. I want fourth row, fourth column, fourth phase, and then fourth cube value, the ratio. So here in this NF is nothing but the starting number is 1, and then the ratios are already represented, and already talked about x1, x2, x3, x4. So x1, x2, x3, x4 all are 4, 4, 4. So if you see this formula, 1 into 3 to 3 power 3 cube, 2 cube, 4 cube, 5 cube. So if I'm multiplying, I'm getting 17 lakh 28,000 as the output, as that GP, geometric progression. So if the person is keep extending this scope of fourth dimensional logic, fourth row, fourth column, and then fourth phase, finally fourth cube. The fourth cube in this particular coordinate, the value will be like 70 lakh 28,000. So I'm trying to achieve it. So how we need to solve these problems and everything I'm sharing here. So the cube 1 will be like this, and then cube 2 will be like this, and it continuously growing into the cube 4. Cube 4 value at the end will be like this. So similar way we can able to achieve for that any dimensional value using these formula.